Okay, so for our next section, and really continuing on in the WLC or Wireless LAN Controller graphical interface, we're now going to begin on the wireless tab. So we've already gone over how helpful help can be. We've looked at the commands, looked at management, skipped security, we're coming back. We've gone to the controller. We're now going to, and we've briefly looked at the monitor, we're going to go to our wireless, and then our WLANs tab. And then we will be going back, once we've set up our AP radios and the wireless LANs that are going to propagate and radiate out over those radios, then we'll be going back and monitoring after we actually, fire up a client and begin some of the actual association of a client, the whole point of this exercise, to the radios. So we're on the wireless tab. And we can see that I have 4 of my 5 APs, because one is in autonomous mode. And I've named them Sales Support Floor 1, AP 1, 2, and 3, and Sales Support Floor 2, AP 2. And we can see the model. So I've got a 1252 AG, an 1131 AG, a 1262N, which also does ABG and N, and lightweight access point or CAPWAP able 3502P. Okay, and this really, the P actually has in this case to do with the 3500, the fact that this one has external antenna capability versus the 3502N that has internal antennas. So I've got 2 ABG-N radios, and I've got 2 ABG radios. They can't do N. We also see the AP MAC address. Now, what MAC address is this? And before we move on, let's just talk about MAC addresses on an access point for a moment, because there's a number of them and they can be confusing. We've already talked about them, but I just want to make sure everyone's clear on this. So we have, to begin with, we always have, if we say the MAC address of the AP, we may be referring to, and in this case it is, the MAC address of the Ethernet. Let's actually go ahead and pull up our switch over here. So if I take a look, let's see if I can actually have both side by side. I'm not sure if we'll be able to have everything that I want here. Yeah, I think we can kind of manage. So I have my APs, okay, and I've got the MAC addresses over here. I can see that, actually, let's go ahead and do show power inline. I think we had them on ports FA011 and 12. Let's just look at FA011 and 12. Let's do a show MAC address table for interface FAS011 and 12. Okay, so here's my MAC address, 70 Charlie Alpha, 9 Bravo 15, 4 Alpha Charlie Echo. And then I've got the MAC for port 12 as well. So if I take a look at this MAC, let's just look at the last 4. It ends in 4 Alpha Charlie Echo, or 4 ACE. Here is that MAC address right here, 4 Alpha Charlie Echo. That's my 3502. It's on port 11. And I was also able to tell that by my show power inline that it was my, I'm sorry, not 3511, 3502 on port 11. Go back up to those show MAC address interface. And I've got 13 Echo Alpha. That's my 1262. Those are my 2 N radios on port 11 and 12. So the AP MAC address is clearly the Ethernet MAC address. Okay, and if we back on the switch we had looked earlier, I'll just expand this out so it's a little clearer. Show IP. If I did show IP DHCP binding, we had seen that 4 Alpha Charlie Echo, or ending in 4 Alpha Charlie Echo, is this MAC address. It's on VLAN 210, and it had gotten an IP address in VLAN 210. Okay. So back on the wireless LAN controller, the AP MAC address here under wireless is clearly the Ethernet MAC address. When we were back on the monitor tab and I had gone to access point summary and clicked on all APs, we had, actually that is the same one. If I had clicked on one of the particular radios, then we had seen base radio MAC. So the base radio MAC is going to be different than if I just go back to monitor, all AP. Okay, so for my 3502, my AP MAC, that's my Ethernet MAC address or media access control address. If I go back to monitor and look at my, let's say, AN radio for, we don't actually see the radio model, so we have to reference it by the floor name. Let's just go back and look at all APs, and my 3502 is named Floor 1 AP1. So Floor 1 AP1. We're going to go back and look at AN. So for Floor 1 AP1, I have a base radio MAC that ends in 6 Delta 70, not 4 ACE, 4 ACE. If I go back and look at, what was that MAC again? It was 6 Delta 7 Echo. I'm sorry, 6 Delta 70. If I go back and look at my BGN, Floor 1 AP also has 6 Delta 7 Echo. Okay, so there's a base radio MAC address, even though those are two separate radios. And then we're going to have a new, so that's basically the B SSID is going to be the base SSID MAC address. But now as I create later different wireless LANs, they're each going to have a different MAC address, the MB or multiple basic service set identifier. Okay, so the MB SSID will be the MAC address that's a newly created MAC address for each radio, for each SSID. So let's go back to wireless. I just wanted to make sure that everyone's clear on what MAC address is assigned where. And we can see how long these APs have been up, whether they're enabled. We can also click on these. Right now, we happen to be on access points, all APs. We can click on any one of these APs. Let's just look at our, let's look at our 3502, our most capable. We can see that we could change our administration status to disable. We see the AP MAC address, which is our Ethernet MAC. We also see the base radio MAC. It's called the base because we're going to create derivatives of this MAC address for the various, well, actually, we're not going to. The AP will dynamically create those MBSSIDs. We don't really need to know what those MBSSIDs are too much. If we want to, we're going to basically throw up a sniffer, a wireless wireless network controller on a laptop in, when I say network controller, I should say a wireless interface on a laptop or smart device or whatever in promiscuous mode, and put a packet capture utility like AeroPeak, or, we're going to use Wireshark here. We talked about the different modes that access points can be deployed in. Here's where we set that. They can be local mode. They can be HREAP mode, which we talked about the new, I'm running 7.0 code here in 7.2 code, and I believe the test is on 7.0, but the new code 7.2 actually calls this Flex Connect. Okay, you could also refer to it as HREAP Office Extend. So if someone refers to Office Extend, this is what they're talking about. We can run monitor mode to sit there and just listen. We can run rogue detector, where we effectively shut off our radio and just listen on the wire in that vicinity for other rogue APs. We can turn it to sniffer mode, where we can basically connect our AeroPeak or Wireshark or something to a remote antenna and listen there. And again, all traffic is going to be CAPWAP and encrypted back to the WLC, and will listen or really gather and download our PCAP files, our packet capture files from there. We can turn it into bridge mode. This is what we're going to use for a mesh network. And we can also turn it to something called SE Connect. What is SE Connect? SE Connect is for Spectrum Analyzer Expert. So there is actually a product called Spectrum Expert. It's basically a spectrum analyzer. Cisco acquired this particular product from, used to be called Air Magnet, basically, but acquired this product, and it is a very powerful spectrum analyzer. It goes way beyond just 802.11 networks, and it can analyze other and accurately identify other types of traffic, such as Bluetooth radios, wireless analog video cameras, microwave ovens, radar, microwave transmission, not microwave oven, but high-powered building antenna microwave transmissions that are not in the 802.11 spec. It can accurately identify these and a lot of other things, inverted wireless signals, things that get into very deep wireless theory, and basically things that will interfere with your network. So we already talked about something called, briefly, we talked about something called Cisco Clean Air, and how the 35 and 3600 series of APs can detect these very same types of information. The reason that they can do that is because they actually have a separate silicon chip on their access point that doesn't really take any processing power away from the CPU. It's independent, and it is outside of the range of just standard 802.11 specification. It is a true silicon-based spectrum analyzer. It's listening to radio waves and able to accurately identify what the types of traffic in those given ranges are based on signatures, based on the frequencies, based on their duty cycles, based on all sorts of different factors that create a wireless signature. Not only can we do this on the 3500 and 3600 series of access points, but Cisco also sells the Spectrum Expert client for a Windows laptop, and we're not going to be taking a look at it, the actual client, here in the CCNA wireless. I could throw it up real quick just to give you a brief look at it, but we're not going to really go into it at all. We do look at it in depth, and it's required knowledge to know that product inside and out for the CCNP wireless site survey exam. But one of the things that we can do with that client is we can actually connect the client, and I should go back and say, when we fire up this client on our Windows laptop, we have to have a Cisco-specific access point card, not access point, but a Cisco-specific card. Or we can connect remotely to an access point, and that's what this mode is, SE Connect. We can use Spectrum Expert to connect to this wireless card, to this wireless access point, and use that as our sniffing card. And the reason we might want to do that is actually when we buy the license for Spectrum Expert, we typically and historically, before this 3500 and 3600 AP came out, we bought a very custom wireless network card from Cisco as a PCM-CIA card. With newer laptops, we just had to have a PCM-CIA to USB adapter that had that very same on-chip or on-board silicon chip that was a spectrum analyzer, specific card or specific chip, an ASIC. And the wireless card was very expensive. Not to mention the fact that I might want to use Spectrum Expert on my Windows laptop and look at various different parts of my wireless network in different cities or maybe even different countries. And so I can connect over the existing infrastructure that we have, the existing local and wide area network, to a WLC, a wireless LAN controller, and therefore connect to one of these APs that's a 3500 or 3600 in SE Connect mode. If I go back and I grab one of these other APs, I don't have SE Connect mode. And the reason is it doesn't have the onboard silicon processor. And it's a very easy thing to know. Can I use SE Connect? Can I use this AP as a Spectrum Expert spectrum analyzer, basically, to connect to? The answer is if it supports clean air, if the AP supports clean air, then it will also support this SE Connect mode. Okay, and that is the 3500 and the 3600 series currently. On the exam, you might only see 3500 series because the 3600 series might have, and I believe it did come out slightly after the publishing of the newer exam, or at least after the writing of that exam. Keep in mind, sometimes when you're taking a Cisco exam, you'll have to keep in mind that sometimes the exam came out in at a certain date, and you might know more, or there might be newer products than, or even technologies, like we said, Flex Connect versus HREAP, than what was available at the writing of the exam. And since they only refresh they typically refresh the Network Associate NA and Network Professional NP exams roughly every, I would say, 18 to 24 months. So about every year and a half to 2 years. And the CCIE exams, they refresh about every 2 to 3 years on a window of about 24 to 36 months, sometimes a little longer, sometimes a little shorter. But you have to remember that when you're taking these associate and professional exams, sometimes newer code base or newer products have already come out. So just, and you might say, well, then how do I know how to answer a question on an exam? Just look at all the possible answers and choose the best possible answer. So if you see, of all these, maybe a question says, written below are all of the current Cisco access points on the market. And you might look and you might say, no, it's not. There's newer access points than that. Then and then it goes on to say, choose the access points that support Cisco Clean Air technology. And the 3500 is there, but the 3600 is not there. Choose the best answer. In that case, there would be only one correct answer. It'd be the 3500. Okay, so just keep that in mind when you're taking exams. Anyway, it's going to tell us about this AP, the primary software version, if it has a backup software version loaded, if it's already downloaded newer software that has come out. Maybe we updated our controller, our wireless LAN controller, and the AP has gone ahead and pre-downloaded the newer software, but it hasn't actually gone through a reboot yet, so it's not really running that yet. What's the bootloader version of software? What's the iOS software? And what's the mini iOS? Okay, what's the difference here? Well, the bootloader is hopefully you understand what a bootloader is, but this is basically a small piece of code that is used just to get the access point or whatever device, router, switch, whatever it is we're looking at, to boot up. And it boots up into its iOS software, which is 12.4.23c JA4. The mini iOS version, this is what corresponds to the firmware that was downloaded from the wireless LAN controller. So this is really kind of a nice way of saying, hey, if I'm at 7.0 on my AP, then I'm in sync with my wireless LAN controller, which is also running 7.0 code. Okay, what the access point is really running is this iOS version, 12.4.23c. So remember, whenever an AP boots up, before it actually downloads its configuration, it's going to upgrade or possibly downgrade to a parity version of or with the wireless LAN controller and from the wireless LAN controller. We see we have an IP address. It was not obtained via static configuration. It was obtained through DHCP. We know that because the static is not ticked. If it was, we could configure it, change things if we wanted to. We also can clear the config except for the static IP if we set a static IP and hit apply. We can clear all config. We can just perform a hardware reset, doesn't clear any config, but just resets it or restarts it. Clearing the config basically sends it back to factory default. This sends it to factory except for the static IP. Okay, we're not going to look too much at credentials right now. Let's take a look at interfaces. We've got our Ethernet interface, and we've got our radio interfaces. We have one Ethernet interface, interface 0, gig 0. It's up, how many unicast it's transmitted received, how many non-unicast like multicast and broadcast it's transmitted and received. We can click on this to get more detailed statistics, frame drops, CRC errors, giants, runts, all that good information that we care about in typical Ethernet environments. Also, is it at 100 full for speed and duplex respectively. Then we can take, and by the way, CDP we have ticked, it's supported on the Ethernet. By default, CDP or Cisco Discovery Protocol is not ticked or supported on the wireless radio 0 and radio 1. Radio 0, slot 0 is the BGN. So this is the 2.4 gigahertz radio. Radio 1 is the AN. This is the 5 gigahertz radio. It's not on those. We can turn one or both on. So radio 0 is 2.4, radio 1 is 5 gigahertz. We can also see that this radio is enabled. Its operational status is up. And because this was our 3500, the Clean Air administrative status is up, and it's actually operationally up. Clean Air is down by default. I've already enabled it, and we'll take a look at where we can enable it when we come to it. High availability. We talked about the idea of a primary controller. Let's go ahead and enter our primary controller. IP address. Whoops, that is the name. Let's put in WLC1 and the management IP. Maybe we would have WLC2 and another management IP. Maybe it would be like 10.2.1.21. And what's the failover priority? Okay, if the wireless LAN controller isn't available, how quickly or how important is it that we fail over? Let's go back into our 3502. I should go back to high availability. I hit apply, but wasn't really done with all the tabs yet. Let's make sure, did I change the mode? No, good. By the way, if I'm in local mode or monitor mode, I have the ability of a sub mode, which is the wireless intrusion protection system. We're not going to enable that now, but if I was concerned about security and I wanted to deal with that, I could do that there. Inventory just tells me the product ID, version ID of the product, serial number. Okay, what is it? It's a Cisco AP. It's a wireless access point. There's a manufacturer installed certificate, and HREAP, remote office access, is supported. We're not going to go into all the things on the advanced tab. We can take a look at our regulatory domains. Country code, US is the only thing available because if I go down here to country, I only have United States checked. Maybe I wanted to do United States and, I don't know, let's say United Kingdom. Okay, and it's going to say that radio resource management channels and power levels are limited to common channels and power levels when I have multiple country configurations to common channels. So basically whatever the lowest common denominator is. Am I sure that I want to have multiple countries selected? If mesh APs are connected, please remove them or use a single country configuration since mesh APs do not support multiple countries. Typically, we're only going to want one country. So I can select multiple countries, but there's rarely a time when that makes sense to do so because typically an access point is not in multiple countries. Maybe I might have an access point on the border of two countries, and maybe I do need to. Maybe it's like US and Canada. I might need to do something like that. But for right now, the country code configured is only US. If I configured another one, let's go back into our 3502 AP. Then I could choose the different country code, and that would give me different regulatory domains, and it would also give me different configuration abilities or parameters or attributes that I could configure for different power levels, antennas, things like that. I can give it a little bit more information about PoE. Am I using 802.3 AF, which is power over Ethernet? Am I using pre-standard switch, such as Cisco inline power? Okay, so the 3500, actually, I should say even the 3550 was inline power, not PoE. The 3560 and 3750 and 6500s have PoE, power over Ethernet. That's the standard. But this might be inline power, so I might want to click that. I might be getting power from a power injector. So that is to say I have a cable coming from the switch, and then before it gets to the AP, I plug a power injector into that cable, and I also plug it into the wall, which introduces direct current or DC voltage up to 15.4 watts into the actual cable, or possibly even more, just depends on the power injector cube 1, 2, 3, etc. If that's going to, or if that's going to inject power into the Ethernet cable before it then gets to the actual access point and therefore powers the access point. So I can deal with things like that. Is the power injector installed? What's the injector switch MAC address? Information like that. We had talked about the maximum segment size and really the MTU being like 2300, a little over, 2356, I think it was exactly, but might be a little off there, of a wireless frame, an 802.11 frame, and how that was a lot bigger than a 802.3 Ethernet frame. Standard 1500 megabit, or sorry, 1500 bytes. Unless we're using anything like giant or jumbo frames in Ethernet, I might have more data put in the wireless payload and therefore have to fragment back at my Ethernet switch, or my switch would fragment for me. If it didn't support the Ethernet size, the jumbo frame, it might not even, just depends on the multi-layer switch capabilities, it might not even forward it. So I can do a TCP adjust, MSS. This is something we can do on most every router, and it's got a default value of 1363, taking into account the wireless headers that are going to be added and the fact that wireless headers are a lot larger than Ethernet headers. So it's basically saying the data payload should only be 1363, and TCP adjust, maximum segment size, is going to inform clients that are sending TCP layer 4 type IP packets on that they can't stuff more than that much data in there. UDP packets typically aren't that big. TCP packets a lot of times are. So we can do that, but this is on the individual radio. We're going to see in here just a moment that we actually have global configuration. With global configuration, we have the ability to set certain attributes, TCP adjust, MSS being one of them, globally for all radios. And it's not necessarily a bad thing to do at all. Something I tend to do so that we don't have jumbo frames or giant frames that are being sent into the switched infrastructure and having to deal with fragmentation issues. Okay, am I able to SSH or Telnet directly to the device? Does this AP support rogue AP detection? I can also group access points together. There is a default group by default. We have the ability to actually group APs together, and we'll be taking a look at that in a little bit. We can create multiple different AP groups and then, use those to collectively assign attributes to them versus one at a time, or versus just globally. Okay, so let's go ahead and click. We can also add a location. So maybe I say Mark Snow's office, and this might get included in traps and syslog. Whoops, can't use that apostrophe. Okay, So we've looked at one radio. We've pretty much looked at all of them. It's just that not all of them support SE Connect mode. Not all of them support clean air. So we've looked at the all APs. Now let's go look at the individual radios for the 5 gigahertz AN and the 2.4 gigahertz BGN. So as I look at these, I begin to see the APs, their base radio MAC, operational status, what channel they're on. Doesn't really look like I can do a whole lot here. Okay. Now, if I go to the BGN, wait, did the AN have something over to the right? Sorry. I thought it did. Over on, I was hoping that this would resize, but it doesn't dynamically resize. So it doesn't look like I can do a whole lot here until I scroll over, is what I meant to say. As I go over, I can see that I can click, or not really click, but just mouse over any one of these radios, and notice that 3 of these radios have configure, details, and information about TSM. We really won't come too much to that in this particular module. But then one of the radios has clean air radio resource management. So let's just take a look at, let's say, my AP2, which is an N radio. And actually, let's go back. And I meant to first click on detail, where we just get a lot of information about the particular access point. So we get the BSSID. We haven't done anything with MBSSIDs yet because we haven't even created wireless LANs or any SSIDs yet. We just have the root BSSID. We have operation rates, whether they're supported or mandatory. So 6,000 kilobits or 6 megabit is mandatory. 9 is supported. This is sort of giving us a summary of what is configured on this particular access point. And more importantly, not just on the access point, but on this particular radio. Because for the access point, we have 2 radios for really each of these APs. So let's go back. And let's take a look. Let me go back to all APs. I just want to make sure I'm looking at the right one. The 1262 is floor 1 AP2. Good. Let's go back to, let's just look at BGN to begin with. And we were looking at AN earlier. So let's look at AP, let's look at floor 1 AP2, which is our 1262N radio operating on channel 6. Notice the little asterisk. That means it's been globally assigned. So there's not a specific channel configured on manually or individually for this particular radio. It's been globally assigned. So let's click on configure. We can enable individual radios. Just like we can enable an entire access point, we can enable or disable one of the radios. Maybe I want almost every radio or almost every access point that you're going to buy today is ABGN. So it has dual radios, 2.4 and 5 gigahertz radios. And with that being said, maybe I want to disable the 2.4 gigahertz spectrum altogether. Now we'll talk later about when that might not be possible with things like mesh networks, but let's just say it's a standard deployment and I want to use only 5 gigahertz because I'm going to be setting up an environment where I know all of my clients have 5 gigahertz capabilities, and that's an important thing to make sure of. Not all clients do. And I'm going to be setting up in an environment where there's a lot of noise, a lot of other APs, like I showed you that I have here in my office building, and I only want to transmit on the 5 gigahertz spectrum. So I could disable the the BGN, basically the 2.4 gigahertz spectrum. I'm going to leave it up for right now. With 802.11n, first of all, is it supported? Yes. And is there something called client link? We're going to talk about client link here. Let me actually go back to a radio that is not an N radio. And notice that 802.11n supported is no, and there is no option of client link even there to tick or check, select. So let's go back. And let's take a look at what client link is. Okay. And we actually saw this when we were looking at our access points on Cisco.com. And we went to products and services, wireless. We went to access points and show products. Some of these we were able to see. There we go. Whether client link is supported. Now this is actually client link 2.0, so it's a newer version. And we'll talk about the MIMO 4x4 later. And we've already talked a little about Clean Air. We're going to demonstrate that. We can actually see, this one doesn't say client link, but it does support it. The 1140 supports client link. Okay, so what is client link? I actually have a good paper on it here. Well, Cisco has a good paper on it here, but I've pulled it up. And what I want to say also is that we've talked about a number of good links to things like whether it be Flex Connect or understanding HREAP. I'm actually going to include in this class a number of links, and I'll create shortened links, Google or tinyURL or whatever, bit.ly, so that they're shortened links. But these are all Cisco.com papers. Actually, one isn't. One is just a very, very deep level of understanding of radio frequency in general, amplitude, frequency, and phase modulation, and all of that, sine waves and everything, if you care to either A, fall asleep to, need something to read and fall asleep to, B, are just want to make your head hurt, or C, actually like me, just want to really understand absolutely every aspect of something. But it's a university paper. But aside from that, I'm going to provide a lot of links. We took a look at Cisco antennas and specific things to that. We're going to look a little bit more when we come to security at the Cisco compatible extensions program and which CCX or Cisco compatible extensions we need to support certain security aspects, because the lab will be testing you on that, or not the lab, but the exam. But we want to talk about client link here real quickly, since we've come to it. What client link is, first of all, 802.11n, we have already kind of talked about how it provided remarkable performance improvements, and I am, yes, reading right here, in throughput, reliability, and predictability. And the ways that it did this were with things called, we talked about how multipath was a bad thing, and how 802.11n turned it on its head to be a good thing, okay, with MIMO, with multiple input, multiple output. And it was able to improve the signal-to-noise ratio by using something called transmit beamforming. That was to basically shape the form of that wireless beam in a way that the client, with only possibly one antenna, could receive that in an optimized fashion. Now, we also talked about if the client had multiple antennas, how they could use something called MRC, maximal ratio combining. So they were either benefiting from having multiple radios and being able to hear, let's say we sent 3 or possibly 4 antenna signals out of an AP, they could hear 2 or 3 or 4 possible signals, and they could hear those each individually and then combine them back together. That's MRC. And the number of antennas to the number of receivers is what we refer to as something by something. So let me just draw this real quick. I briefly, in the 3600 series product page, you just saw it. You saw 4 by 4, okay? Or sometimes you might see 3 by 3. You might see 3 by 1. You might even see 3 by 2, okay? This is the transmit from the radio, how many antennas, how many radios they have, and this is the receiver of the client, how many antennas they have to be able to receive. So the first number is the AP, how many antennas, and therefore how many subsequent radios. And the second number is the client, laptop, or PDA, smartphone, whatever. Okay, that is the number of antennas they have to be able to receive. So if I have three, most Cisco APs until the 3600 have 3 antennas, and most clients have 1 antenna. When the Cisco AP has 3 antennas, and there's only 2 pictured here, what this is showing you is that as multipath and reflection off of different devices occurs, you can see how they get there, but Cisco has very specifically in this drawing shown that they get there at slightly different times. This has, in the past, the fact that there was multipath was a problem. With 802.11n and spatially diverse antennas, they use that to their advantage with either the client having 1 antenna and using beam forming. So very purposefully shaping the beam, shaping the way that this wireless signal is sent out so that they all arrive in a way that complements one another. Or if the client has multiple receive antennas, then with maximal ratio, not G, not MRG, MRC, maximal ratio combining. Okay? So looking back at the client only having 1 antenna, let's just say the client only has, the Cisco AP has, this shows 2, but let's say the Cisco AP has 3 antennas and the client has 1. So we're in a 3-by-1 situation. Okay, 3-by-1, terrible one. In this case, with 802.11n, beam forming worked really well. That's great. We just talked about that. What if this is a 802.11n capable radio, but obviously it has the BG capabilities as well? So .11b and probably more used is .11g these days. And let's say this is a .11g capable client. In other words, the radio, the receiver, wireless card in here is not N capable. So the standard, the industry standard of beamforming can't be done. Why? Because the client doesn't understand it. So there is actually something called client link technology. And what this does, I'm sorry, it's not BG, it's AG. So it's for the 5 gigahertz spectrum. But what this does is that for AG clients, they couldn't do the spatial diversity of beamforming because they didn't have that N standard built in. They didn't know, when the wireless card was built, it didn't have any idea of what even beamforming was. So that code wasn't built into the silicon. So we could, and Cisco originally thought about using compatible extensions, CCX, and we'll talk about more what those are and who participates and which of your laptops you can expect to see it in, etc., which is almost all of them, but not necessarily all. But what Cisco did was they realized we can't necessarily guarantee or quickly enough get out there the ability to have the client really benefit from this beamforming or participate in the beamforming. So what they essentially did was they came up with a technology that basically, and by the way, that beamforming works in 802.11n because the client is actually responding with information, with feedback to the access point so that the access point can maximize or really create the best possible, I should say optimize that algorithm to form the beam in the best way for where that client happens to be located geographically or physically with respect to the surrounding environment, the surrounding multipath, and with respect to the AP. But the 802.11g is not going to have any feedback. So the idea is that Cisco created advanced signaling processing and algorithms so that the 802.11g, or possibly A, I don't know anyone that's deployed A, well, at least not since like 2003, without requiring feedback from the client, because the client isn't going to be able to do it. And therefore, it works with all existing AG clients to not quite as perfectly as transmit beamforming works. I shouldn't say perfectly because it's not perfect by itself, but not quite as good, but still make the multipath into something that is beneficial for 802.11g clients and not disruptive. So instead of not only being not disruptive, but actually improving the ability for it to work, that's what this, or the ability to receive this signal for it to be formed properly, for that beam to be formed custom. That's what Client Link in essence does, without going and reading the whole paper. But I do recommend, it's a great paper to read. I recommend that you go through and look at and read the entire paper. It's very, very informative. We will talk about how Cisco compatible extensions interact with this and other features, but it's not a bad idea, especially if we have 802.11g or possibly A clients, to go ahead and enable this Client Link on 802.11n radios. We can't do this on non-802.11n radios because the radio has to be able to understand the concept of beamforming before it can help. Okay, but it falls under 802.11n parameters because it's a product of that newer specification and of that newer technology. But Client Link has nothing to do with N. It has to do with AG. Okay, and it's probably, I don't know for sure, but probably important that you understand it for the exam. Okay, clean air capable. We were on our 1262. We also see antenna parameters. Are we using all three antennas? We have an A, B, and C antenna. By the way, one of the things that I haven't mentioned yet, but is important, you may have seen a lot of older APs that were, let's say, ABG, but not necessarily N. And the reason I say that is with N, we have more than two antennas possible. With A, B, and G, remember we were sending out duplicate copies of the exact same signal over the two antennas. And what was the reason for that? Spatial diversity. That way, we weren't sending out different copies or different parts of the data as we did with N. We're sending out the same copy. That way the client could determine which of the two signals was a better quality signal, which had a better signal to noise ratio. When we had those two antennas, you might, in fact, let's just minimize this real quickly. You might have seen an AP where those two antennas, especially if they were the rubber ducky type, the dipole, where they came out from the AP and they would go up, straight up. And if you remember their E-plane radiation pattern, it was basically something from it for a dipole, something like this. Okay, so they were each sending out their radiation patterns. You may have seen people that have seen those antennas and thought, oh, it looks cooler if I do it like this. You know, so they actually physically tilted those antennas. Keep in mind what's happening electrically and magnetically. They've very drastically changed the pattern of that beam, of the actual wireless signal. So instead of being sent out omnidirectional across the room like this, they're more, you know, if this is our horizontal axis here, they've kind of tilted the signal, and it's now going into the floor and up to the ceiling. Okay. Not only that, but on top of that, there is the fact that the wavelength for a 2.4 gigahertz or 5 gigahertz respectively, remember when we talked about the fact that frequency we were able to find for wavelength with the math back in, I think it was module 4 or 5, we talked about RF math. And if we know the frequency, we can find for wavelength, right? So if we know that it's 2.4 gigahertz, and that's our frequency, which we depicted by lambda, then we could find for wavelength. So wavelength equaled the speed of light divided by frequency, or lambda. I don't know if I'm drawing lambda exactly right. We just have to divide the speed of light by the frequency, and we'll find for the wavelength. Well, what you'll find in a 2.4 gigahertz antenna or a 5 gigahertz is that they are inches or centimeters apart, depending on how you measure. And the way that Cisco has actually positioned these antennas, and by the way, 2.4 gigahertz and 5 gigahertz, right? 5 gigahertz is just about, not exactly, but just about 2 times, 2 gigahertz or 2.4. So 2.4 times 2 is really 4.8. So just about the same frequency. More importantly, and much more importantly, just about 2 times the wavelength. So 2.4 gigahertz frequency, I believe, is roughly like 4 point something inches. Let's just say 4 inches. So if I have a 5 gigahertz frequency, that's going to be about 2 inches. Okay, the wavelength decreases as the frequency increases. So 4 inches apart from one another, and I'm talking about antenna apart from another, is really 2 wavelengths for the 5 gigahertz. So there's another reason that these antennas should be upright, not only their E-plane orientation of radiation, but also the wavelength for the given 2.4 megahertz frequency within 1 second of time. That frequency is directly 1 wavelength apart for the 2.4 gigahertz, and it's 2 wavelengths apart for the 5 gigahertz. When you begin turning them like this, not only do you change the radiation pattern, but you skew the amount of wavelengths between each other, and they begin to have issues with collisions instead of being working like they should with spatial diversity. So it's actually important with dipole antennas to keep them in an upright position. So they should be basically pointing towards the sky. If your AP happens to be, let's say, flat on the table, and now I'm looking at the top view, then they should be coming straight up. If I'm looking at the side view, this is the side, this is the top. If I'm looking at the side view, then they should be coming out this direction and then pointing straight up, and they should be exactly parallel to one another. Okay, so that antenna positioning is actually not just random. Okay, so anyway, now that we're talking about the antennas, we're talking about an N-capable radio. Do I have the A, B, and C antenna? Is it external in this particular radio? That's my only option. Okay, if so, what type of antennas do I have connected? What's their gain? Okay, do I have a... actually, that particular, the 1260, I have no antenna, so I'm just going to leave that off. If I go to my BGN for AP Floor 1, where I can do configure, let's enable client link, and this says 17. They are most definitely not 17 dBi antennas. I actually only have a 6 dB antenna on A and B. I don't have one on C. Okay, so 6.5 dBi. And it doesn't like 6.5, so let's just give it 6 dBi. Changing the antenna gain can make the current channel unusable. Are you sure you want to continue? Yes. To enable client link, at least both dual mode antennas A and B should be enabled. You have one dual mode antenna. Okay, so actually what I have to do is I have to go back and change my antenna from A and C to A and B. So I'll just go ahead and enable those two. And during the break, I'll make the physical change of that antenna to work with client link. Okay, so not a problem there. We can see that the RF channel assignment has been set to 11, but it's done globally. Okay, this is under global configuration that we'll take a look at. And it notes that only channels 1, 6, and 11 are non-overlapping for the US regulatory domain. I can click custom and I can override that value if I want, but I'm going to leave it to global. If I click custom, I can also change the channel width, assuming that I actually have, well, actually, I would need to be on an AN radio to change the channel width to 40 megahertz. I'm just going to leave it global for now. Not sure if that took effect. I'm not sure if it's just because I didn't have anything to change. Yep, everything's good. Okay. Also, on this 3500, here's where clean air, it's capable and it's disabled by default, but I have gone ahead and enabled it. And I can also have Spectrum Expert connected if I had it in SE Connect mode, which I don't. And again, we'll go over that in the CCNP wireless site survey class. If I go to global configuration, I can see that for any given Ethernet interface on any AP, I might have APs that have more than one Ethernet interface, and more than one or more than two radio slots is CDP enabled. So anything that I do on the radio can be overridden, or I can, basically configure globally. So here's my global TCP adjust MSS. I would turn that on. The backup primary controller. This is in addition. This is actually like a fourth option. So I had primary, secondary, tertiary, then it goes backup primary and backup secondary. Again, anything that you're confused on or just want more information on, click on help. It's not help for this page, but I can go to, I'm on the wireless tab, and then I can look and see I'm under access points, and I'm under global configuration, and I can see something like, let's say, high availability. It says I can configure primary, secondary, backup, which are, if used, primary, secondary, tertiary controllers are not responsive. So it goes in this order: primary, secondary, tertiary, then primary backup, then secondary backup. Okay, so I still want to configure my primary, secondary, and tertiary on each of my APs. You only have to set them up once. Okay, and it gives you all sorts of other information. It's really useful to help. I can also have login to the individual APs if I need to. Do I want to pre-download an image? Do I want to look at AP failover? Do I want to enable that for global AP failover? I'm going to leave it disabled for right now. And what's a heartbeat timer for the AP, discovery timer, etc. Okay? So we're going to come back and we're going to take a look at more information. This was global configuration to all radios, but then there is global configuration to the specific frequencies. So this is global configuration that's only ambiguous across 2.4 and 4 gigahertz. Things like TCP, MSS adjust, or backup controllers, or login credentials, or failover. But then there are things that are specific to each of the 2.4. This is the 5 gigahertz and the 2.4 gigahertz frequencies. And we'll be taking a look at those next.